Okay, so this is section 2.2. We're still talking about proportionality. Now we're just going to get a little more specific on different kinds of proportionality. So things that are in proportion or proportional have a constant ratio. So ways you can think about that: if it's directly proportional, you can talk about the two things. If I double one, should it double the other? If I half one, should it half the other? Is the relationship the same? If I do one thing to one quantity, is it going to do the same thing to the other one? If it's inversely proportional, then it would be sort of opposite, inverse. If I double one thing, would it cut the other in half? If I cut one in half, would it double the other thing? So chapter 1, we have the relationships with inputs and outputs. Then in chapter 2, now we're talking about comparing two quantities. Sometimes the two quantities we're comparing have a special relationship. Like I said, doubling the size of one doubles the size of another. So like the simplest example, the weight of water at 8 pounds per gallon. The weight will double if I double the volume. So if I double the number of gallons, I'm going to double the weight. If I triple the number of gallons, I'm going to triple the weight. Quantities that are linked in this special way of doubling one means the other must also double are said to be proportional. So let's just kind of look at some examples. So these are filled in. Decide which of the following quantities is proportional. Is property tax proportional to the appraised value of your house? Yes, well, and in Virginia Beach anyway. So yes, if they double the value of your house, it's going to double your property tax. How about the population of a region versus the area? So those are not proportional. Just because you double the amount of people that live in a certain place doesn't mean that the area of the place would double. Like Virginia Beach is going to be the same area, the same size, regardless of whether you double the amount of people that live in that area. So how about the population of New York City versus the population of New York State? Those are also not proportional. You can double the amount of people that live in New York City, but that's not going to double the population in the whole state. It's only going to increase the population in the state by the same amount of the increase of New York City. So it's not going to have that same relationship. Let's just use some numbers. If there are 1 million people that live in New York City and 10 million people that live in New York State, if I double the population of New York City to 2 million, then that's only going to increase the population of New York State by that extra 1 million. So it's not going to double the population of the whole state. The cost of buying tickets versus the number of tickets. These are proportional. If you double the number of tickets you buy, then your cost is going to double. The number of accidental deaths in 2005 versus the number of motor vehicle deaths. Again, not proportional, similar to the New York City, New York State example. If total accidental deaths double, it doesn't mean that the number of motor vehicle deaths would double. If you apply some numbers to that, say there were 10,000 accidental deaths and there were 1,000 of those were motor vehicle deaths. If you double the accidental deaths, that's only going to increase the motor vehicle deaths by the amount that the accidental deaths increased. Cups of sugar versus cups of flour in a specific recipe. So if you want the recipe to taste the same, you need to, if you double one ingredient, then you're going to have to double the other ingredients. Otherwise, the recipe is no longer exactly the same. Your IQ versus your GPA. Those are not proportional. You can have a high or low, that should say GPA, not GPS, regardless of your IQ. I know there are some really smart people that are not great students, and there are some people that have smaller or lower IQs, but they're really hard workers, and so they have a nice GPA. Distance to work versus time it takes to get to work. So theoretically, these are proportional. There are a lot of things that go into, the distance that you travel to get to work. You might change locations and it might be like way more stops and starts or way less stops and starts. But on a theoretical level, if you travel at a constant speed and the distance that you go doubles, then it should take you twice as long. Euros versus dollars, again, theoretically proportional because they're exchange rates. So if you double the amount of euros, it should double the amount of dollars that would be in exchange. Miles you drive versus gallons of gas. Again, theoretically, if you get the same gas mileage every time you drive and you double the miles that you've driven, then it should take twice the amount of gas. All right, so things that are proportional in this way, this doubling proportional, are called directly proportional. And there's a formula that involves a constant of proportionality, which the letter K is used to represent. So if it's directly proportional, then you would say y varies directly as x, or x varies directly with y. So notice that the order is important here. If you say y varies directly with x, then your formula starts with y. And if you say x varies directly with y, then your formula starts with x. If something is inversely proportional, where again, like if one thing goes up, the other will go down, or vice versa. So y varies inversely as x, or x varies inversely as y. Then your order is not so important because you can manipulate both of these to just be x, y equals k. Okay, so just some examples. So we talked about that if you double the volume of something, it would double the weight. So if we have 1 gallon weighs 8 pounds, then that would mean 2 gallons weighs 16 pounds, 3 gallons weighs 24 pounds. So you can set those up as ratios and as a proportion. 8 pounds for 1 gallon, 16 pounds for 2 gallons, 24 pounds for 3 gallons, and they all are equal to 8. So that the ratio sort of disappears. You can also go the other way. 1 gallon is 8 pounds, 2 gallons is 16 pounds, 3 gallons is 24 pounds, and if you divide that out, then you get, it's 0.125, but as a fraction, it's 1/8. So depending on the way you approach it, either of these could be considered the constant of proportionality, depending on what the order in which you set things up. And then the constant of proportionality, they would just be reciprocals of each other because you're just setting it up backwards the way that you set it up the first time. Okay, so constant of proportionality, these are based off those, the first examples where we look to see if they were proportional or not. If they weren't proportional, then we have nowhere to go. All right, so we talked about that property tax and the appraised value of your home are proportional. If they double the appraised value, your property tax is going to double. So you would set it up like the property tax versus the house value is your constant proportionality. So you just plug in the numbers that they gave you, and so it's just saying basically that's giving your tax rate is $11.11 per 1,000 value, 1,000 of the value. Population of your region versus the area of the region. So these were not proportional. Just go back and look at when we went through that the first time. So two qualities, or we're just repeating this. Two quantities are directly proportional if when you double one quantity, the other must double. The population of New York City versus the population of the state. Again, no, those were not proportional. The total cost of buying tickets and the number of tickets. Yes, those were proportional. So if we set this up, whatever letters would make sense to you at the time, that's where I'm coming up with these. So we would say the cost of buying tickets is proportional to the number of tickets. And so using these numbers, it's saying that your cost is $24 and the number of tickets is 6. And again, when you're solving, you just have to move anything that is with your variable by the opposite operation. So k times 6, divide both sides by 6. 24 divided by 6 is 4. So your constant proportionality is 4, which just means it's $4 per ticket. The number of accidental deaths versus the number of motor vehicle deaths. Again, we said those were not proportional. Cups of sugar versus cups of flour in a specific recipe. Yes, those were proportional if you want to keep the recipe the same. So let's do cups of sugar is proportional to the cups of flour. And it said there was 1 cup of sugar for every 3 cups of flour. So to solve for k, since it's k times 3, you divide both sides by 3. So 1/3 equals k. And so what that says is that there's a 1/3 cup of sugar for every 1 cup of flour. Okay, IQ and GPA, those were not proportional. Distance to work versus the time it takes to work, yes, those were proportional. So distance to work versus the time it takes to get. So distance is proportional to time. So if your distance is 12 miles and it takes you a half an hour to get to work, divide both sides by the number with k. 12 divided by 1/2 is 24. So the constant of proportionality is 24, which in this case means that you're moving at 24 miles per hour. Euros versus dollars. So we said yes, those were proportional using whatever the exchange rate was. So euros is proportional to dollars, and said 80 euros to $100. You would divide both sides by 100 and you would get 0.8 equals k. So it is 0.8 euros to $1. Miles you drive versus gallons of gas. Yes, miles is proportional to gallons used. If you drive 120 miles and you use 4 gallons, divide both sides by 4, then your constant proportionality is 3, and you're getting 30 miles to the gallon. Okay, continuing on. So again, if you're told that a certain relationship exists, there are formulas that you can set up. This is important if you feel comfortable with proportions. If something is directly proportional or varies directly, you can set it up as a proportion. That is not true if it is inversely proportional or varies inversely. I'm going to use the formulas from right here, though. All right, so the order is important, especially when it varies directly. So A varies directly as B. The first thing equals the constant of proportionality times the second thing. If it's inversely, the first thing equals K divided by the second thing. R varies inversely as T. Okay, T is directly proportional to the square of X. The first thing is equal to the constant proportionality times the square of the second thing. Inversely proportional, X is inversely proportional to Y. X equals K divided by Y. All right, so what if I'm actually trying to solve a problem? You have to start by being able to set it up. So it says X varies directly with U. So let's start with that. X varies directly with U. Then they're going to give us information for X and U so we can find K. So it's going to say X is 15 when U is 18. That's going to allow us to find the constant of proportionality. We're going to divide both sides by 18. So in your calculator, you're going to do 15 divided by 18. Let's see. 15, if you can see that, divided by 18, you get 0.833, or if I do second PRB, 5/6. Constant of proportionality is 5/6. Then the third thing, so that's, what is the constant of proportionality? That's 5/6. And then find X when U is 24. So now this equation that I originally set up, I don't have to use K anymore because I have a number for it. So then that allows me to find X when U is 24. And so I can just multiply this times 24, and my answer is 20. All right, W is inversely proportional to X. So W is inversely proportional to X is how you would set it up. Then they're going to give you values for W and X to find K. W is 2 when X is 8. So here I'm going to do the opposite. I'm going to multiply both sides by 8 because when it's multiplication and you move it, you divide. When it's divided, you do the opposite, you multiply. So 2 times 8 is 16. 16 is the constant of proportionality. And then this formula, I don't need to use K anymore. I can use 16. That will help me answer the question, what is X when W is 14? Okay, a little bit of algebra here. So I need to move this X to the other side. It's being divided, 16 divided by X. So to move it, I would multiply. That would allow that to happen. So I have 14x equals 16, and then I would divide both sides by 14, and you get 8/7. Or you could use the decimal that you got from your calculator as well. All right, more of like a application. The time it takes, so you decide on the variables. The time it takes to travel a given distance varies inversely with average rate of travel. So the time it takes varies inversely as the average rate of travel is the way I would set it up. Then we're going to be told a time and a rate so that we can find K. Averaging 42 miles per hour, that's the rate. It takes Jacob 6 hours to drive to Charlottesville. Again, to move something, do the opposite. So K divided by 42, I would multiply both sides by 42. So 6 times 42 is 252 for the constant of proportionality. And then it took him 4 hours to reach Charlottesville on his last trip. What was his average rate of travel? 4 was the time. I'm trying to find the average rate of travel. So just like before, I need to move the R to the other side. It's being divided, so I want to multiply it. And then I would divide both sides by 4, and I get 63 miles per hour. Move it that way. Okay. A spring extends or compresses in direct proportion to the mass being supported. Spring directly proportional to the mass. If spring A extends 13 centimeters when supporting 100 grams, okay, so 13 divided by 100 is 0.13 for the constant of proportionality. And then how far will the spring extend if it is supporting 20 grams of mass? And you just multiply and you get S equals 2.6. Given the following proportional quantities, determine the two equations representing the relationship. The first one's done for you. So property tax and appraised value. So there's two versions because you can either do the 20,000 or I think it should be 2,000 over 180,000, or you can flip it over. So you would either get a constant of variation of 9 or 1/9 depending on which way that you did it. So if you did euros over pounds, that would give you 113 over 100. So you could either do E equals, let's see, 100 E. I'm doing, now that's my proportion, and then I'm going to cross multiply. So 100 E equals 113 P. So euros equals 113 over 100 P. Or you can do it backwards and do P equals 100 over 113 E. So where everything's just reversed. So cost to the number of tickets is $24 to 6. If you cross multiply, you've got 6c equals 24t. So you can either do 24 divided by 6 is 4t as a constant of variation, or you can flip it around. I put an arrow there. Or t equals 1/4 of the cost. Again, so either order. And wrapping it up, we have a little bit of Excel. This is a conversion table, euros to dollars to yen. So convert $200 into euros and yen. So here's the conversions, and then I have the $200. So you're setting up a proportion. So if I do $200, then I want to come up here from the conversion and set it over $4. And then I'm trying to figure out the $200 is how many euros, and the conversion rate for $4 is 3 euros. So you can set up a proportion there, cross multiply, you get 600 equals 4x, and divide by 4, and you get x equals 150 euros. I don't know why I wrote the E like that. Okay, so that'd be euros. For yen, still $200, and the exchange rate is still $4. But now I want to know how many yen that is. And from here, the $4 goes with 500 yen. Cross multiply, you get 100,000 equals 4y, divide by 4, and it is 25,000 yen. Find equations for euros as a function of dollars and yens as a function of dollars. So basically using the cell references. So if you've done it with numbers, you just have to sort of match up your cell references to the numbers from here. So if we did like here, the $4, that came from C3, the 200 came from B6, and the 3 came from B3. So if we did find equations for euros and function as a function of dollars and yens, so $4 is to 3 euros, so 4 euros equals $3, and as a function of euros as a function of dollars, so it would be euros equals 3/4 dollars. If I do the same thing that here, and I do 4 is to dollars as 500 is to yen from the conversion table, so 4 yen equals $500, so yen is 500 divided by 4 is 125. Okay, so then if we match that up to using the cell references to calculate these things that we did earlier in cell B9, this calculation that we just made here, we can do B3 divided by C3 times B6, because that's the math that we used up here. Okay, remember B3 is the $3, so that's from here, and we multiplied that times the C3, and we divided by B6. Okay, or you can also say B3 times B6 divided by C3. However, that makes more sense to you. In B10, that would be the calculation that we made up here for yen. So you can either say D3 divided by C3 times B6, or you can also say D3 times B6 divided by C3. So you can switch up the order. Okay, that's it for 2.2.